This video, we're going to talk about pointers and some of the issues that come up with pointers. Okay, so I'm going to start by going to the whiteboard. Okay, so we'll pop up the whiteboard here. Takes just a second. Okay, there we go. Okay, so kind of the way memory works on computers, when you run a file, the operating system is going to give you a block of memory. Okay, so this is the memory that you can deal with. Okay, and as we're writing C++ programs, we have this much memory to deal with, and there are two sections that we have to worry about here, and it depends that whether it's at the top or the bottom of memory is dependent upon the operating system, some other things. But in general, one end will be the stack, okay? And the stack are for what we call static variables and static functions, okay? Static meaning that these are the normal variables we've used all along, okay? At the other end of memory, we're going to have the heap, okay? Keep in mind, stack is also a data structure we'll be talking about. And the stack is a stack, but it's not the same as we're talking about. So kind of ignore that for now, okay? So the heap is where we're going to have dynamic things, okay, which we'll talk about. Basically, if you have the new keyword, you're going to have something dynamic, okay? It's going to be stored here. And the heap grows this way, and the stack grows that way, so we don't have to, so they can expand without having to run into each other until they absolutely have to, okay? So in this memory, when we do a normal variable, so say we do int a is equal to 5 in our C++ code, okay, then it's going to create an int sized box. Each variable type has a different amount of bits that it stores, okay, and it's going to put a 5 in it. And this has an address, okay, that all gets bundled up into A, okay? So when we say something like cout A, okay, it's going to first figure out the memory address associated with A. It's then going to return what is there, okay? So it's kind of an all-in-one deal, okay? Pointers, on the other hand, allow us to separate that into two different pieces, okay? So if we create something like int star A, okay, we could also do int star A if you wanted, or int star A. Spacing doesn't matter at all, okay, whichever one makes you happier. I think tying it to the variable itself makes some sense, okay? What this does, this is going to create the address of memory that's int sized as well, okay? So there's nothing there, okay, but it's a pointer to that. If we had an int b is equal to 5, we could then say that, so the asterisk is our first character. We also have the ampersand, which deals with the dereferencing or the address. I could say that A is equal to ampersand B, okay? So this first one would create another box somewhere in memory. We refer to as B, put a 5 in it, okay? And now A, instead of pointing here, will point to this address, okay? So that's the basic idea behind pointers, okay? The other thing to consider is that arrays are pointers. They're constant pointers, okay? So if you say something like int a 10, okay, what it does in memory, it's going to find 10 contiguous spaces that are all int bits wide, okay? It's going to reserve those, okay? So these, we can put a little reserved marker, whatever we're going to do to do that, okay? And then the address of the first position in our array, okay, is going to be returned as A. Okay, so A is a pointer to this address. Okay, this explains why if we do A sub 0, it's going to go to this address and it knows 1 int wide is what we're talking about. If we say A sub 1, it's going to go to this address, then it's going to move over 1, and now we're talking about this second element, and so forth. Okay, so arrays are pointers. Okay, they're the same thing. Okay, so keep that in mind as you're moving forward. Okay, so one of the problems that we have with arrays or with pointers in general is this idea of aliasing. Okay, so aliasing basically is when you have more than one thing or more than one label for the same, let's say, memory construct. Okay, so I'm going to show you some examples in a minute, but basically what I'm saying is if we have an integer a is equal to 5, okay, so we have an int a, we have an int b, so our int a was equal to 5, we have an int b, okay, and then if we say b is equal to a, so here's our int b, we'll have the 5 there, okay, a points to here, b points to there. Okay, as you would expect, you change b, you don't change a. Okay, the trouble comes in when there are bigger things such as objects, members, instances of classes, or arrays. The idea is it may be too big, may take up too much memory. So let's say you've got a big old array here that a points to that. Okay, if I were to say b is equal to a, all it's going to do is make another pointer to that same memory address. Okay, so I don't have two arrays, I have one array. I always like to give the example, it's like you have a kid named Bob. You decide you want 2 kids, but you don't want to go to the trouble of having a second kid, so you also name Bob Tom. So now you've got 2 kids, Bob and Tom, right? But you don't have 2 kids, you have 1 kid with 2 names. Okay, so when you do aliasing, that's what's going to happen. Okay, so let's go back over and look at some code that explains how this works and how we can avoid it. Okay, so get out of here. Okay, get rid of that because I don't need that. Okay, so now let's share terminal screen here. Okay, so we're going to start. I've got a program for non-aliasing. Okay, this is going to use our normal variables. These could be ints, strings, booleans, floats, whatever you got. Okay, take a look at this. So in this case, I'm going to create 2 integers, a and b. Okay, I'm going to set a is equal to 5, and then I'm going to set b is equal to a. Okay, then I'm going to print out a and b. They should both be 5. Okay, I'm then going to change b. Okay, say b is equal to 10. I'm going to print them out again. Okay, we expect that we're going to get a 5 and a 10, right? If not, something weird's going on. Okay, so let's take a look. So let me go ahead and compile this. I'm going to use the a.out because I'm lazy. You should not. Okay, and I get a 5 and a 5 and a 5 and a 10, just as we expected. Okay, so now let's look at an example with aliasing. Again, the thinking behind this from the designers of C++ is that any memory construct could be really big. So we want to avoid wasting that memory space unless we really want to. Okay, so the default behavior is for it to just create another pointer. Okay, so again, arrays are just constant pointers. Okay, and when we use the equal to create a new array, we're only creating a new name. So here we have in our example, we have an integer array A with 5 elements in it. We're then going to go through and set each of those equal to I plus 10, which is going to give us 10, 11, 12, 13, 14. Okay. So we're then going to print out those original values of A. Okay. We're then going to create a pointer called B. Okay. Remember, a pointer is just an array. And I had to initialize that. So I can then say B is equal to A. Okay. So A is a constant pointer to an array. Now B, we're going to set it equal to the same pointer. Okay, we're going to give the values of B here. Okay, and we can go ahead and run that part of it. We'll have to ignore some of the output for now. What doesn't it like? There we go. That's what it didn't like. Okay, so we look up here at the beginning to where I can, okay, my mouse is giving me trouble. So we have the original values of A, the original values of B, okay? We're then gonna go through and double every value of B, okay? So simple enough to do. We'll take a look at our code here. So there we're going to go through and change all the elements of B by multiplying them by 2, okay? We're then gonna print out the doubled values of B, okay? And then at the end, we're gonna print out the values of A. Well, we haven't changed A at all, okay? So we're gonna go ahead and run this again. And we see that the doubled values of B are correct, but A changed as well, okay? So that's a problem, okay? So that's not the way we're gonna do a copy. If you wanna do a copy, you're gonna have to go through element by element and copy those items over. Okay, you have to declare 2 arrays, go through for the whole length and set each element equal to the other element. That will create 2 of those, okay? So this is also going to give us some trouble. We've been talking about classes before, okay? If we have a class that's going to have a memory element, either an instance of a class or a pointer, something like that, or an array, okay, as member data, okay, then we're going to get this aliasing phenomenon going on, okay? So there are 3 things we're going to have to deal with, okay? So, and I'll just start some coding here as I'm talking, okay? So the first problem we have is one we just saw with the shallow copy issue, okay? So the shallow copy issue comes in 2 places. It comes in using the equals operator to create a new class based on a new object based on an old object, okay? So we're gonna have to rewrite that to make sure it does a deep copy. And I didn't say that, but those are the terms. A shallow copy is when you just make another copy of the label, but you don't have 2 objects in memory. A deep copy, you have 2 objects in memory, which is what we almost always want. And again, if you don't, it's called aliasing, okay? So I'm gonna call this pointer class, let's say. Okay, so that's the first problem we have. The second problem comes in also with aliasing if we use the copy constructor. So the copy constructor is where we have a version of the constructor that takes another object, okay? We want to make sure we have that copy constructor to avoid aliasing, okay? And the third one, again, with memory, I talked before about things that are on the heap. We create new elements on the heap with the new keyword, and we delete them with the delete keyword, okay? The normal variables that we create in a program, when that program or that function go out of scope, they're going to automatically be deleted, okay? That's true for the stack. If things are on the heap, so if you allocate something dynamically, then it's the programmer's responsibility to clean it up. So if you create a dynamic array or dynamic variable in your program, okay, then when the program dies, there's no way to get to that memory anymore because there's no label anymore or no handle for it. But the memory is still marked as being used. You can't use it again for other programs, okay? That is what's known as a memory leak in your code. And over time, it will take more and more and more of memory, okay? Some languages like Java and C# have what's called automatic garbage collection. And that there are techniques there to clear out that dynamic memory. But in C++, you don't have that, okay? So you have to deal with it yourself. So we'll go through some examples of those 3 things that we need, okay? Oh, I didn't say the answer to that. The answer to that is we've done constructor files before, which are the name of the class, constructor functions, the name of the class where you set things up. There's also a destructor function, which is the name of the class with a tilde in front of it, okay, that we use to clean up any dynamic memory we've created, okay? So it's going to include the, we're just going to do the constructor here. Let's just forget all that. We're not going to write a test program. Okay. Oh yeah, we will actually. So I'm going to show you how these look like. Okay. So sorry, some indecision on a Wednesday. Okay. So we're going to include our IO stream. Probably not really going to compile this and run it because I don't know if it's going to be complete, but we'll have it there. We need it. Okay. So I'm creating this class. We're going to call it P class. It's a class with a pointer. Okay. So for this, in my private section, int x, this is a nonsense class. We're just doing it to show. And we now have a pointer. Okay. Notice that if we had an array, it'd be the same thing because an array is a pointer. Okay. So we're going to have to deal with that. Okay. If we're not careful, we're going to get aliasing and we're going to get a memory leak in this code. Okay. So then in our public section, we have the following. I'm going to start with our constructor. Okay, constructor, it's going to be called P class. Let's just say we want to take an int a. Again, this is a nonsense class. We're going to set x equal to a, because why not? Okay. Now let's look at our destructor. Okay, this is to avoid memory leaks. Again, it's called a tilde. Okay, that's typically, okay, if it pops up, it's going to pop up. My screen's really slow sometimes. Maybe I missed it. Oh, there we go. I just missed it. It's a shift on my Mac keyboard. It's a shift and then next to the 1 key. Okay. Tilde P class. Okay, which takes nothing. So the constructor fires when you're trying to create a new instance of a class. The destructor files when that object or that instance of a class goes out of scope. Okay, so the program closes down or you delete the object for some reason. Okay. So the only thing we have to worry about in this case is P, okay? So we can do a delete P. Now, if P were an array, we would have to do that, okay? But it's not, so we can just do delete that. Okay. That's it, we've cleaned it up. If there were other memory objects, okay, if there were instances of classes or arrays or any of that, we have to delete each of those, okay? So now we get to the other two things we have to deal with to avoid aliasing, okay? And that's that we need to, first off, we're going to overload the assignment operator, which in C++ is just a single equals, okay? So for that, it's going to be a constant function. It's going to return the address of an object of type P class. We have the operator equals, the operator keyword equals, okay? And it's going to take as a parameter the constant address of a P class member called write object, okay? So just so we're clear on this, let me go down here and get past the class definition into our int main. Okay. Don't want that. There we go. So down here, if I say P class P1, has to give it an name, so that a 1. Could be anything. Okay. Then do a P class P2. Okay. If I want to use the overloaded assignment operator, I could say that P2 is equal to P1. Okay. Again, if I don't overload the operator, then those are going to be one object with 2 names. But since I'm going to overload that operator, it's going to give us 2 distinct objects. Okay. So it's a deep copy, not a shallow copy. Okay. So up in this operator here, I start by making sure that I need to do this. So I'm going to say if this does not equal, okay, to the address of the write object. This avoids a self copy. Okay, the self copy wouldn't hurt anything, but it's just unnecessary. So if I'm saying A equals B, if A already equals B, we're not going to do anything. But if A does not equal B, A points to some different memory address than B does. Okay, then we're going to go through this. Okay, so in this case, all we're going to do is set the pointer. Okay, so knowing when to use the dot, and we'll do both so we'll know. Okay, this sometimes confuses me as well. You got to think about it. Okay, this is a memory variable. It's a pointer. It's a pointer to the object that called this function. Okay, so since it's a memory, we have to use the dash greater than to get to P. Okay, write object is just an object. It's an instance of the function. So we can directly access it from there. Okay, we can directly access the P. And even though P is private, we can get to it because we're a member of that class. Okay, there's no subclass issues or any of that going on. Okay, so that should take care of that for us as far as that goes. Okay, then as far as the copy constructor goes, I seem to have hung up for some reason. I don't know why. Maybe it will come back. Now it's back. Okay. So for the copy constructor, okay, and again, let's take a look at how that would actually be used on my really slow system. Okay, in this case, I could say something like P class P3 is equal to P1. Okay, so in this case, I'm creating P3. In the other equal sign, P2 already existed. So I was using the assignment operator. In this case, I'm constructing a new P3, okay, that I want to use P1's information. Okay, so again, I'm going to have a copy constructor to avoid it being aliased. That's the word. Okay, so all I have to do here is say P is equal to other object dot P. I didn't say what the header looked like. Okay, so this is called P class. It's just a constructor. There's no return type, but it's going to take a constant address. I'm going to call it other object. Okay, and then in this case, since we just have one member function or member data to deal with, okay, that's all we have to do. We're saying P is equal to other object P, okay, and we're done. Okay, so that's all we need. Our examples may get a little more complicated as we go along, but just remember that for each memory variable that you have to worry about a memory leak, which means you have to have a destructor, okay, the destructor function, which is up here, right there. You have to go through and delete everything that is a memory variable, okay? You have to worry about aliasing, so you have to overload the assignment operator, which is right here, okay? And then you have to have a copy constructor as well. Those three things are necessary whenever you have any memory as member data. So any pointer, any array, or any instance of an object, okay? And then this is showing a use of the assignment operator right there, the overload of the assignment operator, and this is showing the copy constructor, okay? So hopefully that makes some sense. We're going to be using pointers a lot as we go through the data structures.